In this lesson you will learn the properties of exponents. So when you have a variable or a number that's raised to a power or raised to a number, that power is called the exponent. So in both of these examples, the letter m is the exponent or a power, and the x and the 2 are called the base. So you have the base of x raised to the power of m and a base of 2 raised to a power of m. So in this lesson we will look at the first three properties of exponents. And the first one is when you have two bases that are being multiplied together, the rule is to add their powers. So as an example, if you had x to the third times x to the fourth, this would simplify to x to the seventh. If you had 2 to the third times 2 squared, this would simplify to 2 to the fifth. The only thing that changes are the exponents. You add them together, but you keep the base the same. You do not multiply 2 and 2 to get 4. In this second example, since the base is an actual number, we could figure out what 2 to the fifth is by multiplying 2 times itself 5 times. And we have 4 times 2, and 4 times 8 is equal to 32. The second property of exponents says that when you're dividing two numbers with the same base, that you subtract the exponents. So if you had x to the fifth over x squared, you always want to start with the higher exponent. Since your bases are the same, it's x to the 5 minus 2, which is x to the third. Since the larger exponent was in the numerator, my answer is in the numerator, whereas if I had x to the 12th over x to the 17th, since the larger exponent is in the denominator, I still subtract them, but I write this as 1 over x to the fifth. Another example would be if you had 2 to the 8th over 2 to the 6th. The bases are both 2, so you subtract the exponents starting with the highest, and since the highest exponent is in the numerator, it's going to be 2 to the 8 minus 6, which is 2 squared, and 2 squared is 4. Whereas if you had 3 to the 9th over 3 to the 11th, the larger exponent is in the denominator, so it's 1 over 3 to the 11 minus 9, which is 1 over 3 squared, and 3 squared is 9, so the answer is 1/9. And the third rule in this lesson is the power rule. When you have a base raised to an exponent and then raised to another exponent, the rule is to multiply the exponents together. So an example would be if you had x cubed to the fifth, this would equal x to the 15th. If you had 2 to the third squared, you would multiply the exponents together and get 2 to the 6th. And 2 to the 6th is something that we could calculate just by writing out 6 2's and taking 2 of them and multiplying them together. We have 4 times 4 times 4, which is 16 times 4, and that equals 64. So for number 1, the directions are to simplify, and simplify means to multiply the numbers together and simplify the exponents. So I have 3g to the 7th times 2g squared. So the 3 and the 2 can just get multiplied to give us 6. And then because we have two variables, both with a base of g, property 1 says that when you're multiplying and you have two bases, the rule is to add the exponents. So 7 plus 2 gives us a final answer of 6g to the 9th. For number 2, we have 8x, or negative 8x, which is the same as negative 8x to the first times 2x to the third times 4x to the fifth. And even though we have three terms this time, we still multiply the numbers together. And if we take negative 8 times 2, we get negative 16. And then negative 16 times 4 is negative 64. Each of these terms has a base of x, and since we're multiplying them together, the rule is to add their exponents. So we will write only one x, but then 1 plus 3 plus 5 adds to 9, so it gives us a final answer of negative 64 x to the 9th. For number 3, 12x to the 8th over x squared. This brings us to property 2. And for property 2, the rule is to subtract the exponents when you're dividing, but you have to start with the higher exponent first. So 12, there's nothing really to simplify with 12 because we have a 1x squared in front. So when we divide 12 divided by 1, we just get 12. And then since we're subtracting 2 from 8, our x goes in the numerator. We have nothing left in the denominator, so we can just write the number 1 and write our final answer as 12x to the 6th. So for number 4, we have 56f to the 7th over 14f to the 9th. So what I'm going to do is I'm going to write out the factors of 56, for number 4, we have 56f to the 7th over 14f to the 9th. So to simplify 56 and 14, I'm going to write out their factors. And 56 is 1 times 56, 2 times 28, 4 times 14, and 7 times 8. Whereas 14, we only have 1 in 14 and 2 in 7. The largest number that they have in common is 14. So 14 is a factor of 56. So I can take this fraction of 56 f to the 7th over 14 f to the 9th, cancel the 14 out, change it to a 1, and cancel the 56 out and change it to a 4. So before I simplify the variables, I'm just going to rewrite this as 4f to the 7th over 1f to the 9th. And you don't have to write the 1. So since we're dividing, the rule is to subtract the exponents, but you want to start with the higher exponent first, which is 9. Since it's in the denominator, you have to subtract 9 minus 7. And the difference will go in the denominator because that's where the higher power is. So this gives us 4 over f squared. For example 5, this brings us back to property 1. We have 3x squared y, and I'll write that as 3x squared y to the first. Whether or not you write the parentheses, either way it's multiplication. and then we have 9x to the first, y to the fourth, and I multiply the numbers 3 and 9 together to get 27, and then the x's, I have x squared and x to the first. The rule is that when you're multiplying, you add them together, and then the y's, I have y to the first and y to the fourth, so I have y to the 1 plus 4, gives us a final answer of 27, x to the third, y to the fifth. For number 6, 4m to the third squared. This brings us to property 3. When you have an exponent outside of the parentheses, you want that exponent to multiply by all of the exponents inside. So you have a 4 to the first and an m to the third. The 2 has to multiply by both of those exponents. The 2 does not multiply to the 4, it multiplies to its exponent. So you have 4 squared, m to the sixth, and you can simplify this as 16m to the sixth. Problem 7 is similar. We have a monomial of 9m squared, n to the third, cubed, and I'm just going to put a 1 as 9's exponent to remind me that I don't multiply the 3 times 9, but rather the 3 times its exponent. And I take this 3 and multiply it by all of the exponents inside the parentheses. And I can do this because 9m squared and n to the third are all being multiplied together. So I have 9 to the third, m to the sixth, n to the ninth, and then 9 to the third, if I figure this out below the problem, 9 times 9 times 9, 9 times 9 is 81, and if I multiply 81 times 9, we get 729. So the final answer is 729, m to the sixth, n to the ninth. For number 8, we have two properties, property 2 and property 3. I'm going to solve property 2 first because I have parentheses around the 6x. So if I write 6x squared, I'll put 6 to the first, x to the first, to remind myself that that 2 will multiply it by both of the exponents. So that I end up with 6 squared x squared, and this is still over 60x cubed y. And one more step before I move on to property 2, I will write this as 36x squared over 60x cubed y. So the first thing is I'd like to simplify 36 and 60. So underneath, I'm going to write all the factors of 36 and all the factors of 60 and find the greatest common factor, which is the largest number that the two have in common. And if I look at my two lists, the largest number that they have in common is 12. So if I divide 36 by 12, I get 3, and 60 by 12, I get 5. So before I simplify the exponents, I'm going to rewrite this as 3x squared over 5x cubed y. And the last thing that I have to do is I have to simplify the x's. The problem is not simplified if you have two of the same letter in the problem. So I have an x squared and an x cubed. I'm dividing, so I have to subtract them, but I start with the denominator because the 3 is bigger than 2. The y, I have nothing to combine the y with, so the y just stays in the denominator. I subtract 3 and 2, and I get 3 over 5x to the first, or you can even write just x, times y. For number 9, I also have two properties. I have 15a times 15a over 120a squared. So the first property is I'm going to multiply the numerator first. I'm going to combine the a's in the numerator and the 15's. So if I take 15 times 15, 15 times 15 is 225. And then to remind myself, I'm going to put the 1's next to the a's because property 1 says that when you multiply variables with the same bases, that you add their powers. So it's 225a squared. And this is over 120a squared. So this time I'm going to go a little bit out of order. In the last few problems, I simplified the numbers first and then the variables. This time I'm going to simplify the variables first. And the only reason why I'm going to simplify the variables first is because I see that both the numerator and denominator have an x squared. So they just cancel. So now all I have to do is simplify the fraction 225 over 120. And so I'm going to make my list of factors, 225 and 120, and I want to look for the greatest common factor. And once I get to a repeat, I can stop and I move on to 120. I'm just going in order, listing all of the numbers that multiply together, writing them in pairs to give me 120. And if I look at my two lists, the largest number that they have in common is 15. So if I divide 225 by 15, I get 15, and 120 by 15, I get 8, so my final answer is 15 over 8. And for number 10, we have 7b to the fourth times 6b to the third over 28b to the 10th. And once again, I have two properties, and I'm going to start by simplifying the numerator. I'm going to multiply the 7 and 6 to get 42, and then I'll add the powers of b. 4 and 3 is 7, so it's 42b to the 7th over 28b to the 10th. So I'll write the factors of 42 and 28 so that I can reduce the fractions first, starting with 1 and again writing the numbers in pairs. And after I check 6, I would check 7, but 7 is on my list, so my list is complete. And for 28, I have 1 and 28. And if I compare my two lists, the largest number that they have in common is 14. So if I divide 42 by 14, I get 3. 28 by 14, I get 2. So I can rewrite this as 3b to the 7th over 2b to the 10th. And property 2 says to subtract the exponents when you're dividing, but to start with the denominator because 10 is larger than 7. So I take 10 minus 7, and my final answer is 3 over 2b to the 3rd.